Let's do a quick overview of naming with me writing and talking at the same time to see if I can help out one more way, presenting this one more way. Whenever I look at a compound to name, the first thing I'm always going to look at is the first element. Is that first element a metal, or is that first element a non-metal? If the first element's a metal, I then need to know, is it a fixed charge, or is it a transition metal? If it's a fixed charge, we know what its charge is going to be. The fixed charge metals tend to be either the first row, that's the vertical row, up and down, first column, I guess, if you want, which are always +1. The second row, which are always a +2. And then there's three more that we talked about in the lecture. Aluminum, which is always a +3. Zinc, which is always a +2. And silver, which is always a +1. So those are the fixed charge. Most of the rest of the metals are transition metals. They have varying charges. For instance, lead can be a +2 or a +4. Copper can be a +1 or a +2. Now you don't need to memorize those charges because remember, we've already got the formula written in front of us and we can figure it out. And if we're going the other way, the Roman numeral will be there and it will help us out. So for instance, as an example, if I have the compound NaCl, one we use over and over and over as our examples, I know that Na is a metal, so that puts me in the metal category. Na is a first row metal, so I don't need to put the Roman numeral with it. So I know that this compound is going to be called sodium. Chlorine, no, it's not chlorine. It's now in a compound, so it changes from chlorine to chloride. So we have sodium chloride. What if it's a transition metal? What if instead I get a compound, for instance, that is PbCl4? Pb is a metal, but in this case it's a transition metal, so I'm going to have to include its Roman numeral. To figure out what its Roman numeral is, I know Pb, for instance, is lead, first of all, but then I'm going to have to include a Roman numeral after it. And to get that Roman numeral, I'm going to look at what it's bonded to. It's bonded to chlorines, which have a -1 charge. There are 4 of them, so it's going to equal a total of -4. The lead has to be opposite of that, so it must be a +4. So in this case, I have lead, Roman numeral 4, not chlorine, but chloride again. And yes, it can get a little more difficult if I have multiple charges on both sides. For instance, playing again with lead, what if I had Pb2 actually I need Pb3N2. Sorry, had to think about that for a second before I did the example. In this case, we know that N has a -3 charge times 2, that's going to equal a -6. So the leads have to total up to being a +6, but we have 3 of them, so we're going to take +6 divided by 3, which is going to equal a +2. So this is the case where we have lead, Roman numeral 2, nitride. Not nitrogen, but nitride. And then the last example is, what if instead of starting off with a metal, we start off with this box up here of a non-metal? For instance, I have S2O4. S is sulfur, that's a non-metal. So in this case, I need to tell you how many of both the non-metals are there. So I have to say that I have disulfur, and I have tetraoxide. So I have 2 sulfurs and 4 oxygens because I have a non-metal bonding to a non-metal. I hope this helps a little bit. Thank you.